Okay, so today we're going to be starting in on circles and talking about circumference and area as well. I think the first thing we should talk about would be some vocabulary. And so the first thing we talked about today in class is how many points are on a circle? And there are infinitely many points on every circle. And so, and the truth is that every point on the circle is equidistant from the center of the circle. And then also, if you connect any 2 points on a circle together, you'll make a chord. And there are infinitely many chords you can draw in a circle. The longest chord you can draw goes through the center of the circle, and that's called a diameter. And that's shown right here. And then, and there are infinitely many diameters you can draw on any circle. And so that's kind of fun as well. A radius is the distance from the center to a point on the circle. And on every circle, that length is consistent. Okay, so like within one circle, all the radii will be congruent. And then let's see what else we've got. I can color code these. You guys can color code your notes as well. A line that passes through 2 points on the circle is called a secant line. So if it intersects a circle at 2 points, it's called a secant. And then something else that's not on our list below, but if it touches a circle in just 1 point, it's called a tangent line. And that point that it touches the circle is called the point of tangency. And there are lots of different lines you can draw, but those are 2 examples of some lines you've got. So if we go to talk about a circle here and say, okay, name this circle, how you name this circle would be circle O. You name it by the center, or you can draw a circle and then you write the name of the point in the middle. Okay, so this is circle O. The chord, a chord is a segment that connects any 2 points on a circle. So AB would be an example of a chord. Also, CD would be another example. Those are the 2 chords that are labeled on that diagram. A radius could be AO, could be OB, another radius could be OC, and then also OD. A diameter would be AB. And you can write segment in front of each of those measurements, or you are certainly welcome to draw a segment over it. You've got to do one or the other. You can't just do AO. You have to do a segment over it to signify it as a segment. Is CD a radius? And the answer is no. Why? Well, a radius implies that it connects the center with any of the points on the circle, and that does not touch the center. So therefore, it is not. Okay. Also, if OD is 4 centimeters, what would be A to B? That would be 8 centimeters, because a radius is going to be consistent throughout the whole circle. And if both of these are radii right here, then the entire distance across the circle would be 8. Okay. Moving forward, for circles to be congruent, the radii have to be congruent to each other. So if you took out a compass and you draw a circle, okay, with a certain radius, and you draw another circle with the same exact measurement on your compass, you would get 2 congruent circles. All circles are similar. They're the same shape, okay, as each other. They have the same proportions. And one example of this is if you take the circumference of any circle over the diameter of that same circle, the answer will always be pi. Okay, and so it's kind of interesting that, yeah, that ratio, those proportions are always consistent between every single circle. Okay, concentric circles are going to be, they share the same circle. So I've got a picture in the back of my room about concentric circles. It's a famous painting by Kandinsky, and the centers are the same, but you just increase the radius and keep drawing additional circles that are a little bit bigger but share the same circle. So that's an example of concentric circles. Okay, on the back of our notes, we're going to practice finding what's it called? The circumference and the area of multiple circles. The circumference is a distance around a circle. It's like the perimeter. And so it's a length. So if you run around our track, you're like, oh, I'm going to run a quarter of a mile, okay? Or you're going to run certain number of yards or certain number of inches or something. So a length around a circular object, okay, is going to be a dimension that's going to be linear. And so you can either do 2 times pi times r, or you can change around the order of those because multiplication is commutative. You can change the order of anything you multiply, and it shouldn't change the answer. So you can do 2 times the radius and then times it by pi to get the answer of a circumference, or double the radius is actually equal to the diameter. Okay, so you could do the diameter times pi as well. And label these in inches or feet or miles or meters. Again, if you're running around a circular, silo, you're running a certain number of feet or inches or whatever you're talking about. Area is going to be like the amount of space within a shape. And so you find the area of rectangles, and circles would be the radius squared times pi, and you label that like inches squared or feet squared, etc. If you buy a house, they're like, how many square feet does it have? That means how many literal tiles that are a foot by a foot could you fit in that house on the floor? And so it's a good way to show how big how much space is within a rectangle or a floor or something like that. And so we would use cubic measurements to go 3D. So linear is going to be around a shape. Area is going to be how much is inside of a space, inside of a flat surface. And then 3D would be, we'll deal with the volume later on. So with that in mind, let's move forward and say, what would be the circumference and the area in terms of pi for this shape? So diameter is 18. We want to find the circumference is equal to pi d. So the diameter is 18, and you times it by pi, and that'd be centimeters. And that's the exact value of circumference. If you want to find the approximate value of the circumference of that circle, you're still going to do pi d, but you're going to type it in your calculator. Use the pi key. And you're going to get approximately, so that's why I use those little markers, 56.5. And that'd be centimeters. So both of these are true. The question is, do you want exact, which would be the top answer in terms of pi, or the approximate, which is going to be the decimal. Okay, let's run it off. Because pi is an irrational value. And so you have to round if you choose to use pi. And to get the decimal approximation, and that pi, in terms of pi, would be the most precise. Area, on the other hand, is going to be the radius squared times pi. So if the diameter is 18, the radius equals 9. So 9 squared times pi, or 81 pi. That would be centimeters squared. Okay, anything time you do area, it's something squared, square area. And then if you do 81 pi, you're going to get 254.47, and that's centimeters squared as well. Okay, if you do the same with the next shape, it says use the radius of 15. So the circumference is pi d. So the diameter would be 30. So it would be 30 pi. It would be feet. If you use your calculator to figure out the approximation is about 94.25, and that would be feet as well. For the area, you do the radius squared, 15 squared, which is 225, and you times it by pi, and that's feet squared. If you put that in your calculator, you're going to get 706.86. That's feet squared as well. So the exact is going to be in terms of pi. The approximate would be as if you type it into your calculator. The next few are going to be us saying, can you work backwards? If I give you the area, I can find the dimensions of the shape. And so if I give you the area formula is area equals pi times radius squared. If I give you the area, it's 49 pi equals pi times r squared. To solve this, you had this on your last test. You can divide both sides by pi. Now, because it already has a pi in this side, you can, when you divide it, it cancels out. If you didn't already have a pi, you could use your calc to be whatever it is divided by pi, use your calc and you get a janky decimal. In this case, we're just dividing by pi and there's already one, so it cancels out. So this answer is going to be really easy. If it didn't already have a pi in it, you would get a janky decimal. Okay, and then to get plain old r, you square root both sides. You get r is equal to 7, and that's centimeter. If you want to find the circumference, you double the radius, you get 14, and you could put pi, and we could do centimeters. If you want to see what the decimal is, you could put that in your calc. Over here, circumference equals pi d, okay? And so they give us the value of circumference, it's 32 pi, and that equals pi d. To get d by itself, we're going to divide by pi. Because it has a pi, the pi's will cancel out on the left side. If you didn't, you would just find the quotient of the two numbers, the value they gave you divided by the pi key, and you'd get a Yankee decimal. So in this case, 32 is equal to the diameter, and that's in centimeters. And so that means the radius is going to equal 16 centimeters. Okay, the next thing we're doing is that it says area is equal to pi r squared. They tell us 13 pi is the value of the area. So that's pi r squared. Divide both sides by pi, you get radius squared equals 13. To get plain old r, we're going to square root it. Well, that means the radius is equal to square root of 13. Now, there's a decimal, and you can find it if you want to, but the radius being the square root of 13 is actually the exact answer. And so if you wanted to find the circumference, you could do it, circumference equals 2 times pi times r. So you could do 2 times pi times the square root of 13, and that's in inches. That's completely fine. If you want to put in your calculator, yeah, you can. You can do 2 and then times pi and then times the square root of 13. And the approximation is 22.65. It just depends what you're doing with it, as to say, do I want the exact or do I want the approximate decimal? The last one is if circumference equals 15 pi, that equals pi d. Divide both sides by pi, and they cancel out in this case, so 15 equals d. That means the radius equal to 7.5, and that would be centimeters. Okay, the last two are a bit of a review from what you've done before. They give us, they say find the circumference, and they tell us this dimension here is 6, and this is going to be 8. And they say find the circumference. Well, we need the diameter, so draw it in. And we have a right triangle because it's a rectangle. Now, the truth is, you might notice it's a right triangle, so you can do Pythagorean theorem. You also might notice that the legs are 3 and 4, and that is the dilation of the Pythagorean triple 3, 4, 5. Where the legs are 3 and 4 and the hypotenuse is 5. So you can do the Pythagorean theorem where you do 6 squared plus 8 squared equals c squared. That's going to give you r squared equals 100 or r equals 10. Or you can realize, hey, guess what? It's a dilation doubling every dimension of the Pythagorean triple 3, 4, 5. Where 3 and 4 are legs and hypotenuse is 5. And so to find the circumference, you just do pi d. The diameter is going to be, I don't know why I put that. This is C. The diameter is 10, so that'd be 10 pi, and that would be centimeters, or 31.4 centimeters if you did approximate. The bottom one, okay, the bottom one has legs of 5. This is a 45, 45, 90. It tells you it's isosceles. It means the hypotenuse is 5 root 2. And then, as a result, to find the circumference, you could do circumference equals pi d, or 5 square root of 2 times pi, and that's in terms of inches. If you want the decimal approximation, you could just type that in your calc and get approximately what it is. All right. Well, here's today's lesson. Thank you so much. Have a good day.